So we are starting with number types. So there are different groups of numbers that we start talking about. And the first group in the center is called the natural numbers. So natural numbers are numbers that you use to count things with. So if I'm counting, say, apples or desks or cars in the parking lot, then as I count them, I start with 1. So 1 car, 2, 3, and then dot, 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 which means and so on. So 4, 5, 6, etc. Above this, the next level up is the whole numbers. And they're nested because essentially whole numbers contain all of the natural numbers or the counting numbers plus the number we use if we don't have anything. So if I look at the parking lot, there are no cars. I start with the number 0. So 0, 1, 2, 3, and so on. Okay, so now I can count things. Then as time goes on, we want to also be able to track things like, hey, it's 10 degrees above 0, it's 10 degrees below 0. So we add this new thing in, and we call these the integers. So 0's in the middle, and then we can say, okay, so I'm climbing up the ladder. So I want some positive numbers. But then what if I'm digging a hole? So I also add these new numbers, the negative numbers. And so those extend both directions, both positive and negative counting numbers, essentially. And again, nested because all integers contain the whole numbers, and whole numbers contain the natural numbers. Okay, so above integers is the next level. So the next level is going to be rational numbers. So rational. And rational numbers is essentially anything that can be written as a straight fraction. So if I'm looking at 2, for example, I can write that as 2 over 1. So 2 over 1. So all rationals contain all the integers and so on. So any rational number. So 1/2, 4/5, -10/3 are all rational. On the other side, as decimals, 0.5, 1.36, 1.3 repeating, so 1.333. So anything that either stops as a decimal, is a repeating decimal, or can be written as a fraction. Okay? Then something that is also a set of numbers, but we cannot contain them in the sets we've talked about so far. So down on the bottom, I'm adding another set called irrational. So the irrational numbers. These are special numbers like square root of 2, okay, square root of 5, cube root of 6, and then special identified numbers like the circle constant pi. So pi, for example, 3.14159 ... So irrational numbers are numbers that when you write them out as a decimal, they don't terminate and they also don't repeat. Okay? So we basically have 2 sets of numbers right here. The rational set on the top, the irrational set on the bottom. All these numbers together make up what is called the real number set. So real numbers, which is all of these types of numbers. So, and anything essentially that you can measure. So using a measuring tape, measuring out around a circle, all these numbers so far can be generated with that kind of idea. So we can get some kind of measurement, or they get generated from doing, basic mathematical sets. Okay, so those are the numbers these exist on the number line. So let's add that. So these are on this regular number line. So for example, pi 3.14159, I can put a dot and say, hey, that's there on the number line. Okay. So we're going to go down because now we have another set of numbers. Notice this is not contained in any of the real box because this other set is called imaginary. Okay, and I can make up whatever value I want and say, hey, that's a number. But the reason why imaginary numbers become important is because it turns out they actually do affect things. So they're kind of like atoms. They're invisible, but yet they make up stuff that is important in certain applications. So electronics, some higher level mathematics, it turns out these numbers are sort of invisibly out there. Okay, so they're called imaginary numbers. And the big idea is that these numbers have the value of I in them, which is the square root of -1. That number is not on the number line. So any imaginary number, 2i, -5i, 3/4 I. So if you stick I on there as a multiplier, then that is considered an imaginary set. Okay? So now what we have is the real set on the number line and the imaginary set, which is I. And then if we go up to the very top, we then have the entire set. So everything all together, which is called complex. So complex sets. So any complex number, A plus BI. Okay, so this contains the real numbers because I can have 10 plus 0i, which is 10. So all the real numbers are in there. And then I could have 0 plus 6i. So all the imaginary numbers are also in there. And then the complex set itself, if I have a standard regular complex number, I would have something like 2 plus 3i. And that is the number sets.